Hi everyone. In this question, we're being asked which table of values, okay, and we've got four of them here, represents a linear relation. Okay, so linear meaning that there is a direct proportion, okay, or a partial, what we might call a partial variation there. Essentially, what's going on here is as the independent variable increases, the dependent variable changes by a proportional amount. Okay, so let's just take a quick look through here. So which one of these is linear here? Let's take a look at this first one, distance and time. Now, in almost every case where we do stuff like this, time is the independent variable. So let's just take a quick look at this. I go up a second, I go 5 meters forward. Up a second, 5 meters forward, up a second, 5 meters forward, up a second, 5. That's a pretty good indication that this is linear here, because that's all very consistent here. If you take a look at this one, time and distance, and again, it oftentimes it makes most sense to think about time as the independent variable. Okay, in 3 seconds, the distance increased by 10. In the next 3 seconds, the distance increased here by 12. In this next 3-second interval, this one's now gone up by 14. And you can see that there's this inconsistent increase. Okay, this can't be linear, because when I have this nice consistent increase in the value of the independent variable, but the dependent variable is increasing by an increasing amount. Okay, 10, 12, 14, and I'm assuming 16. Now let's take a quick look over here. Okay, and again, let's treat time as if it's the independent variable. To go from 0 to the first second, speed has gone from 0 to 1. For time here, if I increase by another second, I increase by another meter per second. I increase by another second. Now it falls apart, because this one is now gone up by 2. And if I go from 3 to 4, increase by 1 second, again, this has now gone up by 4 to 8. What's happening here at this point is it starts this doubling pattern. Okay? And that's actually what we would call exponential. This is changing by an increasing amount. That's not good. That's not linear at all. Now let's take a quick look at this one. Distance and speed. Okay, well this one's a little bit more difficult to determine which one might be the independent variable. I mean, you think about speed might depend on distance. Distance actually could depend on speed. It depends on how you want to interpret it here. It doesn't really matter. Let's just see if we can find a consistent relationship. So when the distance goes up by 4, in this case, the speed went up by 2. So now, when I go from distance from the next interval here, this has gone up by 12, and this one's still gone up by 2. Notice that the speed here in the next section goes up by 2, and then this actually goes up. It more than doubles. This is going up by, what is that, 16, 32. So that's going up by like 20, and then more and more. So again, this isn't linear. One of them is going up by this nice consistent amount, but the other variable isn't. Okay, and so A has to be the one that's linear here. Now, another way of talking about what we've just been looking at here is slope. Okay, and you may have discussed that already. Slope, and we use M to represent slope, and I know that seems a little weird, but just live with it. That's okay. This is the change in the y variable over the change in the x variable. Change in dependent over change in independent. Okay, and so if we treat, for example, distance here as being the y variable here, maybe we find the slope between these two values here. I would go 10 minus 0 over 2 minus 0, and that would give us a slope of 5. Now, that in itself is not all that significant, but let's take another pair of points here. Let's say we take the last two values here, and we'll take a look at the slope again. In this case, the y value is 20 minus the initial y value of 15 over 4 minus 3. And again, we end up with 5. And that's the whole point that we're trying to get at here, but in a slightly less formulaic way, what I was doing before. Here, I'm just trying to identify that the relationship between those variables is consistent. Okay. So anyway, come down here. I'm looking for A as my answer, and it's oddly enough, it's B, because B is A.